have to give back to you today, but I figure you've got notes. You can probably survive. How do you graph this? I want you to sketch it. Do you remember how to do this? This was that whole end behavior first. Okay, what's the degree of this polynomial? 4, that's an even number. What's the leading coefficient of this polynomial? -1, that is negative, right? If you have an even degree polynomial and a negative leading coefficient off that table, it's down, down. So yes, you could have that table on your cheat sheet. Or you could memorize it. Does this look familiar? Okay, now once we do that, what? X-intercepts. And then we have to figure out if we bounce or cross. Remember that? Okay, so to find the x-intercepts, what we do is we set the thing equal to 0. And we begin to try to factor. And there is a GCF here. What is our greatest common factor here? X squared, right? And I'm actually going to pull a negative x squared out. I'm doing a negative x squared because I don't like to leave a negative on my leading term. So I pull negative x squared out. That leaves me with a positive x squared, a minus 5x, and a minus 14. Do you all agree with that? That's what would be left if I pulled an x squared out from every one of those terms. And then this right here factors. It's a quadratic. And I promise you on the test this will factor. You just have to be able to factor it. You need to know how to break that down. So what is this going to be? It's 7 and 2, but which one is negative? Which one's? It's minus 7 and plus 2. And so what we have here are 3 x-intercepts. 0, 7, and -2. How am I getting these? Setting that to 0, setting that to 0, setting that to 0, and you get these 3 answers. But I also need to determine if I bounce or cross at these x-intercepts. So how do I determine that? If what's even?
The degree.
The degree. So the degree here is 1, the degree here is 1, the degree here is 2, right? If it's even, what happens? If it's an even number, you bounce. And if it's an odd, you cross, and here you'll cross. So I'm going to bounce off 0, I'm going to cross through at 7, I'm going to cross through at -2. It's time to graph. So I draw my x and y axes. And what should I put next? Put the x-intercepts. Put 0, 7, and -2. Those are dots, right? Now your graph does this. On the left side it goes down. On the right side it goes down, right? We know that already. And so all we have to do is connect the dots. If we go up, when we get to -2, what am I going to do over there? I'm gonna cross through, and then I've got to get back to 0, but when I get back to 0, I'm going to bounce off, and then I go back up, and how high do I go? It doesn't matter, right? I told you it doesn't matter. Then back down to 7. When I get to 7, cross through, and then go ahead and join up with that other part of your graph. That's it. All right, let's look at number 8. For number 8, the difference is that I've given you another polynomial function, but it's already factored, right? It's already factored. Our test is on Halloween, isn't it? You know what? Okay, so look, if you use a cheat sheet, I won't penalize you. If you don't use a cheat sheet, I'll give you the 5-point bonus. Okay? That's your Halloween present. Yes?
What if we come in costume?
What if you come in costume?
I like that.
I'm afraid to open that.
But your costume.
5 points. 5 points for coming in costume. I mean, we're walking around campus all day in a costume.
Yeah, come on, that's embarrassing.
Yeah. Yeah. No. We'll just go with everybody gets to use a cheat sheet, but if you don't use one, you'll get a 5-point bonus. All right. Now this one is just like number 7, except that it's already factored, which is good. But then there's also a drawback to it. What's the drawback to the fact that it's not factored? I mean that it is factored. I don't know this part as easily. I have to think about it a little bit. So what does this act like? What does this behave like? Well, this is like x to the first power, right? What does this one behave like? Like an x squared, and these are being multiplied. And this acts like an x to the third. So when we put these together, you add up the exponents. 3 plus 2 plus 1 is 5, 6, so x to the 6th. This thing is acting like an x to the 6th. And the leading coefficient would be 1, right? So we have, pardon? The leading coefficient is because this is a 1, and this is a 1, and that's a 1. And I'm not going to give you anything other than that. Yeah, if you multiplied them out, you'd always have a 1 there in front. Now, it would be more complicated if I put something in here like -2, but I'm not going to do that to you. Yeah. Okay, so this is going to go up on the left and up on the right, because that's what even polynomials do, even-powered polynomials do if the leading coefficient is positive. So up, up. All right? And because we are running out of time, let me move quickly here. What are the x-intercepts of this function? 0, 3, and -4. What do I do at each of these? What's the power on this one? Odd, I cross. Power on this one? Even, bounce, and then odd, cross. So now I draw it. I set each of those factors equal to 0. So if you set this factor right here, if you set that equal to 0, you'd move the 4 to the other side, and it would be -4. I mean, you have to actually write the equation down. X plus 4 equals 0, and then subtract 4 on both sides. All right, so 0, 3, and -4. It goes up on the left, up on the right, and it bounces off at 3, right? So starting from here, I'm going to cross through at -4, go back up, I've got to cross through at 0, and then perfect. I'm going to bounce off 3 and then go back up there. If when you're doing this, like you wind up here, but then your arrow goes down here like that, like something is wrong, right? You've messed something up. It should all go together at the end. All right, number 9. All right, find the x and y find the x-intercepts, the vertical asymptotes, and horizontal asymptotes of this rational function. I may not have time to go through this. Number 9. Let's see, f of x is 2x squared minus 8 over x squared minus x minus 20. How do you find the x-intercepts of a rational function? Set the numerator equal to 0. So I would take the top, set it to 0. I would factor out a 2 because I have a greatest common factor, right? And then I would recognize x squared minus 4 as being a x plus 2x minus 2. That's a difference of squares. That's a common thing we should recognize. right? X squared minus 9 would be x plus 3x minus 3. X squared minus 16 would be x plus 4x minus 4. And now set these equal to 0. How many answers am I going to have? Only 2. Because you would set 2 equal to 0, right? But 2 can't be 0. So that is not part of our answers. You set this to 0, you get negative 2. You set this to 0, you get 2.
Only if there was an X.
If there was an x out there, then yes. So if that was 2x out there, it would, 0 would be an x-intercept. Because you would set 2x to 0. And then you could divide both sides by 2. And you get x is 0 over 2 is still 0. So you get 0. But if it's just a number by itself, it can't be 0. All right, that's the x-intercepts. How do you find the vertical asymptotes? Set the denominator to 0. So the vertical asymptotes, you set the denominator equal to 0. This one is one that factors. So this factors, and then that means you have 5 and negative 4 are your vertical asymptotes.
For the vertical asymptotes, is it like negative 2, 0, and then 2, 0?
Wait, for these?
Yeah.
These, if you wrote them like that, I'd be okay with it. But if you wrote them as points, it'd be negative 2, 0, and then 2, 0. The danger with that is over here, these verticals are not points on the graph. They're dotted lines, so just leave them like this. All right, that's verticals. How do you find the horizontal asymptotes? You have to compare the degree of the numerator to the degree of the denominator. And there were 3 cases, remember? 3 cases. We are looking at the case right now where the degrees are the same. What happens when the degree is the same? You divide. You do the coefficient. You do the 2 here divided by the 1 there. What the hell? And you get y equals 2 over 1, which is 2. So y equals 2. Did y'all watch the baseball game last night? Man, I'm shooting left. Yeah. They won, right? Okay. Saw the... I'm not a big baseball fan, but I enjoyed the game last night. It was good. Okay, we're done with that one. Number 10. Okay, I'm really out of time here, so let's just talk about number 10. Number 10 and number 11 are where you go and you make the t-table and you plug in values into the function. Do you remember what values I said to plug in? Negative 3, negative 2, negative 1, 0, 1, 2, 3. And you just draw a little sketch. You're going to have number 10 will be exponential growth. The other one will be exponential decay. 10 and 11, yep. Now number 12 was from last class. You have those 2 formulas, right? The shampoo formula and then the other one. So $7,000 is invested at 4.5%. What do you have to do with that 4.5% if you're going to use it in the formula? Turn it to a decimal, 0.045. All right, so for that problem, number 12, P would be 7,000, R would be 0.045, T would be what? 6 years, right? So 6. All right, part A says weekly. So I'm going to use that formula, not the PERT shampoo formula, the other one that has N in it. And when I say weekly, how many weeks are there in a year? We'll say 52. So N would be 52. For B, it's monthly. So you use that formula again. N is 12. For C, you use the shampoo formula. Okay? Now what about number 13? I want you to do number 12, but this time your money is only in there for 6 months, not 6 years. So T there would be what? 0.5. T would change from 6 years to 0.5 because 6 months, half a year. All right. Hope that is enough for you all. Have a good weekend.